Hi. Yeah, I'm not dead. Not yet, anyway. It has been a lot of work with my real work. We are opening up a new facility and take a lot of time. What I want to show you is not a complete project. I'm doing a small work with drilling some hole in the cooling fan or cooling fins. Actually, for I don't know if you can see it. It is what's called a low noise amplifier for microwave, and it needs some cooling. And the one that I've used before, it had a different cooling part and different dimension basically. So it's quite precise, as you can see. It's actually in inches, I believe. It's American part, but then it's 10th or 100 of millimeters. So the only way to do this is in my small mill. Otherwise I need to make the hole much bigger. It's M2, or actually it's inches, but M2 will work. So I have my drilling machine that I bought a couple of years back. The idea to have this metal milling machine is to be able to do basically whatever parts I want. It's a quite small machine. It's, I would say, it's good precision. I can keep 10th, and if I'm really want to, maybe 100th of millimeters. If I really want it. It's a small machine, as I said. It has good tolerances. One of the best investments I ever made for this machine is this DRO, Digital Readout Unit. I bought this as a kit maybe 10 years ago, even more. And I put it together myself. Somebody else have done all the constructions. I basically got it as an IKEA part and soldered it together and all that. I did some small modification on the digital readout units to get better performance out of it. But the whole idea, for you that are not familiar with mechanical machines, is I can move this table this direction, I move that direction, I can move the complete head up and down. So this is the y-axis. So if I crank here, you can see the numbers in millimeters changes, and I can go back to 0. And as you can see, it readouts in hundreds of millimeters, so I can keep 100 millimeters tolerances as long as the vibration doesn't kill me. Nowadays you can buy these units from China, and I think they are good quality. This is okay. It do everything I wanted to do. Of course you always dream of something better, but it works. I would like to have something for my lathe as well, but some days. So anyhow, now I'm gonna drill 6 holes in this part, and I need to keep really tight tolerances, otherwise it will not fit. So what I have done here is I zero it on the edge first, both edges, measure how wide and how thick it is, and crank it in so the drill is on the center of the piece. Then I zero X and Y again, and now I can go from there and drill the six hole symmetric around center. So the first part here should be 11.915, the half of 23. So I then start to move my machine over here, and I want that to be minus, since I'm off axis from the 0, minus 9.2 is the closest I can get. Yeah, I think that I call that a day. What is suggested to do then is to, if I want to be this precise, I can lock the slides on the machine with this part, and I can lock it in that direction with that one. So I have a 2.5 millimeters drill in. It's actually this part of things of drill we use in the lathe that is rather thick, otherwise it would flex. And I will countersink it at the same time, because I want the head of a screw gonna be flush with this surface. So I just turn it on. And I think I need some coolant, otherwise it's gonna go bad. The best thing for aluminium is alcohol, but you can get nice headache out of it, so try if we take this universal thing. So, nice hole. And let's see, just double check. If my N2 disappears, yes it does. Fine, all happy. One done, 5 to go. So, now I'm gonna take the other part that is plus 11.92. So, let's loosen it, going to a little bit too far. As you can see here, my mill, there's a threaded bar in the middle that's move a table for you that is not familiar with this type of machines. I bought this second hand, and I notice when I'm in the center of a table, that part is rather worn. So I had a lot of what's called backslash. So when I change direction, going that direction and change going that, I need to crank the handle quarter turn before I grip again. That could be fixed by replacing that part, but I never come around to do it. And yeah, it's in the region. If I would have used it more, I would be rather annoyed by it and then fixed it. But now I use it now and then, so it's okay for me. So I can keep that locked. Now I have drilled that hole. I started with that one, and I drilled that one, and now on these lines I'm going to take that one and that one. So in between those there are 22.76. It also says there, so they are centered. So I need to go minus 22.76 and plus 22.76. So I'll loosen this part and start going minus 22.76. Too much. Come on. Yeah, so lock it. Some cooling oil. So then we (22). I'm happy there. I'm not sure what public I have on my channel really. So since my intention is to be the Renaissance man and do a little bit of all, I think I'm also gonna explain things that maybe if you do this kind of work as a hobby as me, it's stupid to explain it. But when I drilled, I went down, let it up, go down and let it up. And the whole idea is that the chips that sticks to the drill, you never get them out of the hole otherwise, and they do a lot of friction, and then you burn the drill or snap it. So you drill it a bit, let it up, and take the chips up. You can go down again. Makes things much easier. So that was a little bit about a milling machine that actually I did some drilling in. So that's all for this video. A short one, just showing I'm alive, I'm doing stuff. Also doing stuff that I forgot to film, and I thought that, oh, this would be a good video. Try not to do that and post short one, not as a long one I posted last time, what was 1.5 hours. So small, tidy ones. So this was all about this machine. I want to finish this up since it's one of the last hot summer days, they have said. So I want to do this and jump in the pool, maybe for the last time this summer. So it's gonna be evening and the lights on, but I speed up this work and then I can relax later on. See you later. Bye.